Hi everybody. We're still talking about 1.6, but now we're talking about graphing the secant and cosecant functions. You still need to look at the posted notes to see the base graphs that list the vertical asymptotes and the key points. Okay, and we're going to get right into graphing some examples. Okay, so we're going to start out by graphing cosecant. The graphs of these two functions, like you can see from the base graphs, are very similar. They do have different key features in terms of location, but the shape of the graph is very similar. Okay, so the first thing we're going to do is just start by finding the start and end point like we always do for the trig graphs. Okay, so remember for the cosecant graph, okay, the start point is 0. Okay, and the end point is pi. Oh, I'm sorry, it's 2 pi. Okay, so now we're going to solve for x. Okay, so we get that our graph is going to be between negative pi over 2 and positive pi over 2. Okay, so let's draw our graph. Okay, and I'm just going to start by labeling by pi over 2's. So I'm going to start here with negative pi over 2, and then I'll go over here with positive pi over 2. Okay, and I'm going to include our vertical asymptotes that we know are at that point. Okay, now this graph, if you look at the base graph, has a third vertical asymptote. It's right in the middle, so halfway between pi over 2 and negative pi over 2 is here at the axis. Okay, but this leaves us with an issue, right? Because we don't have anywhere to put our two key points. We have all of our asymptotes labeled, but we don't have our key points. So I'm going to go halfway between pi over 2 and 0. That's pi over 4. Okay, and then I'm going to go halfway here. That would be negative pi over 4. Okay, so for this graph, there's really only two key points. They're right at the bottom of those cup shapes part of the graph. Okay, so we really only need those two. Okay, so normally, okay, the first point here is at 1. Okay, but from the question, our y transformation moves it up 1. So we're going to move it up 1. Okay, and then we're going to draw our one that faces up. Okay, these are kind of parabola shaped. They're not parabolas, but they are U-shaped like a parabola. Okay, our second one is normally starting at negative 1. We're going to move it up 1, starts here at 0. Okay, and then I'm going to draw that one which faces down. Okay. All right, let's do another example. Okay, so we're going to start by doing the start and end point. Okay, so this would give me x equals pi over 2, and this is going to give me x equals 5 pi over 2. Okay, so let's draw our graph. Okay, so because they're both pi over 2's, I'm just going to start by labeling pi over 2. So I'm going to go 1 pi over 2, then I'll have 2 pi over 2, 3 pi over 2, 4 pi over 2, and 5 pi over 2. Okay, now remember at the start and end point is where our vertical asymptotes are. And our other vertical asymptote is right in the center. So you guys can see visually that 3 pi over 2 is right in the center of these. Okay, And we actually don't need to split up the interval because we already have these marks where our key points should be. Okay, so we're going to look at our y transformations. So our y transformation is a vertical stretch by 2. Okay, so normally this point is at 1. 1 times 2 is 2. So the bottom of this part of the graph is going to be at 2, like this. Okay, now the bottom of this part of the graph is normally at -1. -1 times 2 is -2. So the bottom of that part of the graph is going to be at -2. Okay, so you can see when you do have this stretch, these two parts of the graph will be further apart than normal. Okay, so they are stretching away from the axis, they're stretching away from one another. Okay, so secant has a very similar shape of graph. So let's look at some examples for secant. Okay, so again, we're going to find the start and end point. Okay, now for secant, the starting point is on the base graph is -π/2. Oops. Okay. And the end point on the base graph is 3π/2. Okay. All right. So we're going to do our graph here. Okay, and because they're both over 6, we're just going to start labeling like that. So here's going to be 1π/6, then I'll have 2π/6, 3π/6, 4π/6, 5π/6. So that should be a little further out. Okay, so 1, 2, 3, 4, and 5. Okay, now I'm going to draw in my vertical asymptotes. Okay, and remember there's one that's in the center. Okay, so here's my center one. Okay, and again, we don't really need to cut up the interval because we already have it cut up enough. Okay, so normally my key point here is at 1. Okay, so I'm going to move it down to 0. Okay, normally my key point here is at -1. So that means I'm going to move it down to -2. Okay, so unlike the previous example, because these are just shifted, they're still 2 units apart. They're just further down, where when you stretch them, they'll actually get further apart. Okay, let's do another example with secant. Okay. Okay, so again, the start point for this one is -π/2. And the end point is 3π/2. Okay, so we're going to solve for x here. So this is going to be -3π/6 plus 2π/6, which would be -1π/6. Okay, so this is going to be -π/12. Okay, and then here, 9π/6 plus 2π/6 is 11π/6. Okay, so that gives me 11π/12. Okay, looks good. So let's do our graph. Okay, and because they're both over 12, we're going to go ahead and start labeling by 12s, okay? So here's negative 1 pi over 12. Here's positive 1 pi over 12. 2 pi over 12. 3 pi over 12. 4 pi over 12. 5 pi over 12. Ooh, I'm going to run out of room here. Hang on. Okay. So here's 1. Here's 2. Here's 3. Here's 4. Here's 5. Here's 6. Here's 7. Here's 8. Here's 9. Geez. Okay, 10 and 11. I'll do 11 right at the very edge of my paper here. Okay. All right. So I guess I could do 11 out here. Okay. So I'm going to put in my asymptotes. Okay. It's kind of hard to get them both on camera. And then I'm just going to do whatever is exactly halfway. Okay. So you can do it visually like I am right here, where I'm just kind of like counting in. Okay. So here 5 pi over 12 is my halfway point. Okay, and then I'm going to use that same method really to do my other one. Okay, so you can see over here how I'm going to do my halfway point. Okay, so it's at pi over 6. Okay, so I'm just going to put a little mark here. Okay, so normally my key point here would be at 1. Okay, so remember the y transformations are reflection and then move it up 1. Okay, so I'm going to reflect it and then I'm going to move it up 1. Okay. All right, so here on the other side, okay, we'll find our halfway point. Okay, so here, okay, so normally that's at -1, we would reflect it, and then we'd move it up 1. Okay, so this one's going to be at 2. Hang on. Oh, I'm sorry. If this is reflected, it certainly wouldn't be facing up, would it? Okay, now the reason I could tell that was wrong is because when I was looking at the graph, the two shouldn't overlap, and I was thinking if this one is faced up and this one is facing down, they're definitely going to overlap. I forgot that I was doing a reflection when I drew my graph, so this one should be facing down because it's reflected. Okay, now this one should be facing up, okay, because it's reflected. Okay, and there we go. Not the prettiest points in the world, but it works. All right. Again, I encourage you guys to practice. There's no other way to get good at graphing other than practicing, and I'll see you guys soon.